Good morning, children. So today we are going to discuss how to solve linear differential equation. Okay, solving of linear differential equation. So in the last class we discussed that So in the last class, we discussed that the general form of a linear equation takes the form dy by dx plus py is equal to q, isn't it? A linear differential equation takes the form dy by dx plus py is equal to q, where p and q are functions of x. Where p and q are functions of x. If it is like this, first you have to find the integrating factor. Integrating factor is given by e raised to integral pdx. Okay, learn this by heart, children. Integrating factor, 1 mark question and all will be asked. What is the integrating factor? Integrating factor is given by e raised to integral pdx. What is p and q? They are functions of x alone. It must be a function in x. Constants and all are allowed, but no y term will be allowed. Okay, then the solution is given by, what is the formula for solution? Y into integrating factor is equal to integral of q into integrating factor into dx plus c. Y into integrating factor is equal to integral of q into integrating factor into dx plus c. Okay, this is the formula what we learned the last class. So a linear differential equation takes the form dy by dx plus py is equal to q, where p and q are functions of x alone. Okay, note down dx by dy form is deleted. Dx by dy form is deleted. Okay, only dy by dx form is there. Okay, now we can, once we do the questions, it will be more clear to you. Write the question. We are doing exercise questions. Exercise 9.6, few selected questions we are going to do. Rest, you have to do it as homework. Today itself, you do try that one. Okay, so write the first one. Solve dy by dx plus 2y. Solve dy by dx plus 2y is equal to sin x. Dy by dx plus 2y is equal to sin x. How to solve this? Okay, so 3 methods we have learned till now. First method is variable separable. What is the name of the second method, Gauri? Homogeneous method. First one is variable separable. We separate the variables, x terms with dx, y terms with dy. Okay, second method we have learned is homogeneous. In homogeneous method, we substitute y is equal to vx. Therefore, dy by dx is v plus x into dv by dx. The third method is linear differential equation. So once the question is given, they will not give by solve by this method, that method and all will not be specified. You have to observe the equation, go through the equation, check it. Is it possible to separate? Look at there. Is it possible to take x terms separate and y terms separate? Is it possible? Is it possible to separate there? No, isn't it? We can't, because with dx we can't take like this. Now, is it homogeneous? Here we have 1. What about here? 0, isn't it? Sin x. So it is not homogeneous. It is not homogeneous. Then the third method, then in this case, we have to use the method, the linear form, dy by dx plus py is equal to q. Is it in that form? Comparing, you can write what is p. P is 2, q is sin x. You compare it with the general form. What is p? Coefficient of y. What is the coefficient of y here? 2. Q sin x. Once we write p and q, first you find integrating factor. Integrating factor is e raised to integral of p dx. So e raised to integral of 2 dx. E raised to integral of 2 dx, that is equivalent to e raised to 2 is constant. What is integral of dx? It is x. So integrating factor is e raised to 2x. Now we have to write the solution. Therefore, what is the solution? Solution is y into integrating factor is equal to integral of q into integrating factor into dx plus c. Y into integrating factor is integral of q into integrating factor into dx plus c. So y into e raised to 2x is equal to integral of e raised to 2x into sin x dx plus c. Now we have to integrate e raised to 2x into sin x into dx. We have to integrate. How to integrate this? Here we have to use integration by parts. Okay, so I'm going to name this as I1. I'm going to find out this separately. Y into e raised to 2x is equal to I1 plus c. What is I1? Where I1 is integral of e raised to 2x into sin x into dx. So this one we have to integrate it separate. Okay, we have to use integration by parts. So I'm considering the first one, I1. I1 is integral of e raised to 2x into sin x into dx. We have to use integration by parts. So integration by parts, which one is your first function? Which one will be the first function? For selecting the first function, we use the rule ILH. Inverse function, is it there? No. Logarithmic function, is it there? No. Algebraic function? Trigonometric function is there. So this is our first function. The remaining will be the second function. So it is first function is sin x. Second function is e raised to 2x into dx. So what is the formula? Integration by parts. First function into integral of second function minus integral of derivative of first function integral of second function into dx plus c. So first function, here the first function is sin x. E raised to 2x is the second function. So when we apply integration by parts, first function is sin x into integral of e raised to 2x into dx minus integral of derivative of first function. What is derivative of sin x? Derivative of sin x is cos x into integral of e raised to 2x into dx plus c. So that is e raised to 2x by 2 into sin x minus integral of cos x into integral of e raised to 2x is e raised to 2x by 2 into dx plus c. Okay, once again we have to integrate. Once again we have to integrate by integration by parts. So minus 1 by 2 is constant. Okay, again we'll get cos x e raised to 2x into dx plus c. So when you integrate this, for the time being, if you are not writing c, no problem. Finally, we can write that c. Okay, because when we integrate, this function will never become 0, isn't it? When we integrate, the same function will be getting repeated. So again, once we integrate this, e raised to 2x by 2 sin x minus half into, again use integration by parts. Cos x is the first function, e raised to x into 2 dx is the second function. So first function into integral of second function minus integral of derivative of first function. What is derivative of cos x? What is derivative of cos x? Yes, it is minus sin x. Integral of second function into dx. So that is e raised to 2x by 2 sin x minus half into cos x into e raised to 2x. If we integrate, e raised to 2x by 2. Minus of minus, it will become plus integral of sin x e raised to 2x by 2 into dx. For the whole thing, there 1 by 2 is there. 1 by 2 is common there. So that is equivalent to e raised to 2x by 2 sin x minus, when we open the bracket, it will become cos x e raised to 2x by 4 plus into minus 1 by 4 integral of sin x e raised to 2x into dx. So look at here, this model we have discussed earlier. The same function, is it repeated? It is I1, isn't it? The same function. Whenever we get e raised to x and sine, e raised to x and cos, that function will get repeated. So we can write this as I1. I'm taking this term to other side. Plus 1 by 4 I1 equal to e raised to 2x sine x minus cos x into e raised to 2x by 4. Now take the LCM there. Take the common LCM. So we will get 5I1 by 4 is equal to 4 e raised to 2x sin x minus cos x into e raised to 2x by 4. So the denominator 4 will get cancelled. Therefore, what is I1? E raised to 2x, you can take it as common. 4 sin x minus cos x by 5. By 5. This I1.
Ma'am.
Sorry, children, here by 2 is there. 1 minute, here by 2 is there. So it will become 2 only. Here 1 by 2 is there. So it will become 2. This is 2. Okay. So I1, after finding I1, substitute this in the first equation where we stopped. Okay. We wrote this y is equal to, substitute here. Therefore, the solution is y into e raised to 2x is equal to I1. What is I1? Now we have calculated. What is I1? 1 by 5 into 2. 1 by 5 into, what is the form? E raised to 2x, 2 sin x minus cos x by 5. Substitute it there. 1 by 5 into e raised to 2x, 2 sin x minus cos x by 5 plus c. 1 by 5 into e raised to 2x, 2 sin x minus cos x plus c. That is y into e raised to 2x is e raised to 2x, 2 sin x minus cos x by x 5 plus c. This is the final solution. Here, okay, so the first step is, children, we have to check whether it is in the form dy by dx plus py is equal to q. Dy by dx plus py is equal to q. That is the form. If it is there, then write the integrating factor. Once you write the integrating factor, then write the solution. Okay, what is the solution? Solution is given by y into integrating factor is integral of, is it okay? Is it clear, children? Okay, children, is it okay? Nandana, Srihari, Dia. Rijas are able to follow? Last 2 class you are not there. Is it okay, Rijas? Okay. Huh? This is okay. This is the third method we are learning. First 2 methods, variable, separable, and homogeneous. Okay, this is the third method in differential equation. It's an important topic. Okay, now write the next question, children. Write the next one. Solve 1 plus x square. Solve 1 plus x square into dy. 1 plus x square into dy. 1 plus x square into dy plus 2xy dx plus find the particular solution. Write the question. dy by dx plus 2y tan x. dy by dx plus 2y tan x plus 2y tan x is equal to sin x, comma, y is equal to 0 when x is equal to pi by 3. Y is equal to 0 when x is equal to pi by 3. dy by dx plus 2y tan x is equal to sin x. Compare it with the standard form. What is the standard form? dy by dx plus py is equal to q. Compare it. Comparing, we can see that what is p here? P is with the y. With y, what is there? 2 tan x, isn't it? And what about q? Q is sin x. Write the integrating factor. What is the integrating factor? E raised to p dx. So e raised to integral of 2 tan x dx. 2 constant, we can take it outside. Integral of tan x. What is integral of tan x? What is integral of tan x?
Log sec x.
Nia, what is integral of tan x? Learn the formula. Naurin, what is integral of tan x?
Log sec x.
Integral of tan x is log sec x. Yes, Achyut. So it is e raised to 2 log sec x. Now listen, children. Listen, look at this point. Note down this point. What I am going to do, we are going to apply the property of log. We write this as to e raised to log sec x the whole square. We are applying the property. What is n log x? Log x, n log x is log x raised to n. E and log will get cancelled. Therefore, what is integrating factor? Sec square x is the integrating factor. We are applying the property. Integral of tan x is log sec x. Then what we do here, this 2, we are taking it to the power. Now e and log will get cancelled, so we'll get sec square x. Now write the solution. What is the solution? Y into integrating factor is equal to integral of q into integrating factor into dx plus c. So y into sec square x is equal to integral of q. What is q? Sin x into sec square x dx plus c. Now how to simplify this? Sec means what is it? It is cos, isn't it? So we can write this as sin by 1 cos x into 1 by, okay, the rest, another one you keep it as such, plus c. Sec square x means we can write this as sec x into sec x. And what is the sec? It is 1 by cos. So 1 sec we are writing it as 1 by cos. The other one, let it be like that. Now what is sin by cos? Tan x, isn't it? Tan x into sec x into dx. Now what is integral of sec x into tan x? What is integral of sec x into tan x? It is sec x, isn't it? So it is sec x plus c. So y into sec square x is equal to sec x plus c. It is the general solution. This is the general solution. But they have asked the particular solution. Particular solution means the values are given. Initial values are given. Y is 0 and x is given as pi by 3. When you substitute y is 0 and x is pi by 3, what you will get? 0 is equal to sec pi by 3 plus c. Therefore, what is the value of c? What is cos pi by 3? What is cos pi by 3? Cos pi by 3 is 1 by 2, isn't it? So here it will be sec means it's reciprocal 2. So c is minus 2. The value of c is minus 2. After finding c, write the solution. Therefore, the solution is y sec square x is equal to sec x minus 2. This is the solution. This solution we call it as particular solution because we find out the particular value of c. This is called the particular solution. This is called the particular solution. Is it okay? Aryan? Nia? Turn on your video, Nia. Check it. Is it okay? Do these questions again and again. Formula, learn it. Do these questions again. Okay? Is it okay, children? Emmanuel? Okay. The next one. Write the next question. dy by dx minus 3y cot x. dy by dx minus 3y cot x is equal to sine 2x. dy by dx minus 3y cot x is equal to sine 2x. dy by dx minus 3y cot x is equal to sine 2x. Okay, so again the method, compare it with the standard form. What is this? Okay, this type is easy, children. You compare it with the standard form. If you are thorough with the formula, we can do it. So compare it with the standard form. dy by dx plus py is q. So with y, what you have, that is p. Therefore, what is p here? With y, what is the term we have? Minus 3 cot x. And what is q? Sine 2x. Once you write p and q, the next step you write integrating factor. So what is the integrating factor? E raised to integral p dx. So e raised to integral minus 3 is constant, minus 3 cot x into dx. What is the integral of cot x? What is the integral of cot x? Integral of cot x is? Yes. What is the integral of cot x? Yes, Punya? Integral of cot x is log sin x. Integral of cot x is log sin x. So we can write this as e raised to minus 3 log sin x. Again, apply the property. E raised to log, apply the property of sine. Sine x raised to minus 3. Okay, this number, we can take it to the power. E and log will get cancelled. So we'll get sine raised to minus 3x. That is same as 1 by sine cube x. What is 1 by sine? It is cosec. So it will be cosec cube x. Integrating factor is cosec cube x. So once the integrating factor is given, write the solution. Y into integrating factor is cosec cube x dx is equal to integral of q. Q is sine 2x cosec cube x into dx plus c. Now what is sine 2x? Sine 2x, we can write this as 2 sine x cos x, isn't it? We can write this as sine 2x means it is 2 sine x cos x into cosec cube means 1 by sine cube x into dx. So one sine will get cancelled. So 2 you can take it outside. What is cos by sine? Cos by sine, we can write this as cot x into cosec x into dx plus c. Integral of cot x into cosec x dx plus c. That is same as, what is integral of cot x cosec x? It's minus cosec x. plus c. So y into cosec cube x is equal to minus 2 cosec x plus c. Now substitute the value. Substitute the initial condition given there. What is the condition given there? When y is equal to 2, when y is equal to 2, x is equal to pi by 2. Substitute the values here. So 2 into cosec cube pi by 2 is equal to minus 2 cosec pi by 2 plus c. Cosec 90. Sin 90 is 1, isn't it? So cosec 90 will be also 1. So 2 is equal to minus 2 plus c. Therefore, what is c? Value of c is 4. C is 4. So substitute here. This is the solution. Here you substitute. When c is 4. When c is 4, what is the solution? When c is 4, the solution is y cosec cube x is equal to minus 2 cosec x minus 2 cosec x plus 4 minus 2 cosec x plus 4. Is it okay, children? This method is very important. Okay, this method is very important. And one more thing, the 19th question is also deleted. Dx by dy form is not there for you. Dx by dy form is not deleted. Only dy by dx form is there for you. Dx by dy is deleted. Okay? Is it okay, children? So today your work is try the questions in this exercise. Okay? We have done 2 or 3 questions from the particular solution and general solution. The rest of the questions, do it because each and every question in this exercise is important. And if you have any doubt, just leave a message. Okay, complete this. The next class will be starting with the new topic, vector. Be ready with the textbook. All the maths classes attend with your textbook and pencil, pen and all. Okay, okay, children. We wind up. Thank you.